So we're looking, what is this, Math 321? I think this is our second day for doing chapter 3. This is day 7 of class, maybe day 5 of lectures. And this is support for chapter 3, part B. So previously we had done some exponents and the hell. We've done some stuff with exponents and square roots, and we did order of operations. Today we're going to look at a couple things. First thing we're going to look at is the sigma notation. That is capital sigma. And when you see that symbol, it means add shit up. It's exactly what it means, add shit up. Sigma notation, another word for it is called summation notation. Where sum, the word sum is the outcome of addition. We will usually see sigma with some kind of setup. It'll be either there's some function here. They might put like 1 and a 5 like that. They might also write this as I equals 1 with a 5 up there. And they'll have something else, some kind of function in here. The I is called the index. And you'll see where I will show up in the function. There will be an I in it. And we're going to do an example. And it's probably easier to do the example than to keep jibber jabbering. Sometimes you see an N instead of an I. Those are the two most common ones. So let's take a look at the notation. Actually, I'll set up the notation for the problem we're going to do here real quick. We've got I equals 1 to 4. And we'll have like 3i minus 2.5 over 4. And there will be a square in there. We'll throw the square in there. That I equals 1 and the 4 means let I equal 1, 2, 3, and 4. So it kind of gives you like a starting point and an ending point. Two, 3, and 4. Which means I'm going to, first off, I'm going to plug in 1 for I. And then I'm going to add that to where I plug in 2 for I. And then I'm going to add that where I plug in 3 for I. And then 4. So what we've had is 3 minus 2.5. I just kept replacing I with 1, 2, 3, and 4. Now, this is much easier as a table. But I think seeing it written out, does that make sense what we're doing with the I? I'm plugging it in for the I right here. And we still need to, like, we haven't multiplied it out or anything, but we need to multiply it out and do stuff like that. But then we just go 1, 2, 3, 4 and add them up. If this said I equals 1 to 6, we would have 2 more, yeah, a 5 and a 6. It doesn't always start at 1, usually it does. It usually starts at 0 or 1. So let's look at a table version. Let me rewrite it down real quick. Now, looking at what's going on up here, there's no I in the 4. So something that's convenient can happen is we can do the summation first. And then divide by 4. These two are going to resolve the same thing, which makes it a little bit easier. We have less dividing by 4. So I'll make a little table. And we're going to do 1, 2, 3, and 4. First off, I'll do 3i minus 2.5. So I have 3 times 1 minus 2.5 equals, maybe I'll put the outcome in this column right here. That is 0.25. Or I'm sorry, 0.5. That ends up being 3 minus 2.5, which is 0.5. You can do these all on a calculator to speed them up. Here we have 3 times 2 minus 2.5. 6 minus 2.5 is 3.5. Then we do 3 times 3 minus 2.5. And we've got 9 minus 2.5 is 6.5. And then we do 3 times 4 minus 2.5. Which is 12 minus 2.5, which is 9.5. Next, we'll do the squaring of that. 3i minus 2.5, and we'll square it, which means I'm just going to take this column and square it. 0.5 squared is 0.25. That's the only one I know without my calculator. I don't know what 3.5 inch squared is. .5 squared is 12.25.
How do you do it on the calculator?
My calculator has a little square button.
Oh, that little.
It's got a 2 up above it. The caret also works. The caret means do exponent. So for 6.5, I'm going to go 6. Oh, you can actually see it over here. 6.5. And then my square key is right there, the x squared. Right there. And I square it and 42.25. And then 9.5 squared is definitely over 81. 90.25. So we did all of the 3i minus 2.5 squared. Now we got to do the summation part. The summation I equals 1 to 4 just says add those up. So we're going to add 0.25 plus 12.25 plus 42.25 plus 90.25. 54, 55, 90. I think that's 145. I try and do that in my head. 0.25. Yep, 145. All right, so far, where we're at, we're doing the I equals 1 to 4. We're doing 3i minus 2.5 squared divided by 4. And what we've got it down to so far, I'm off screen, is this top part added up to 145. And then divide by 4. 145 divided by 4 is 36.25. One of the questions on the support quiz is like this. Figure out how to make it work, Melinda?
I'm missing something. I don't know what I added. I think I'm just adding it wrong. Oh, that's what I did. Okay. I was putting 9 instead of 9.
I'll do it.
2.5.
Does anyone need this up longer?
36.25 is the answer.
Yeah, 36.25. Now, the reason why this shows up in this chapter, and I'm not going to walk through it, but I'm going to show you. The formula for standard deviation looks like this. We got the summation. We got one thing minus another squared divided by a value. The only thing different is they do take the square root at the end. So when we're doing standard deviation, the computer is going to do all of this for us. But this is the mechanics behind what's doing it. I'm just expediting it real quick just to show you how bad it gets without actually walking through it all. Even if there's only 9 numbers, we got to find the average first, which is the X bar. Then we got to do all these. I listed the XI, which is each entry. Then I did the XI minus X. Then I squared it. Notice there's a lot of calculator work right here. Lots of ways to fuck up the calculator. Then I added them up. Then I divided and I took the square root and got a value. There's a lot of ways to fuck this up by hand. You get to use the calculator computer, so you don't need to do it by hand. But that's the point in the summation notation, and that's why they have it on the quiz. And the homework for the support course. Other stuff we have in this section is, there's a lot of it in this section, algebraic expressions. I just want you to see how bad and ugly it was without having to fill out your notes up with shit you're not gonna do. That's why I showed that last page. Algebraic expressions, this is where we, well, we had letters in just a second ago. This is math stuff that has letters in it. And these letters are called variables. The reason why they're called variables is because they vary in value. They can equal different amounts. Fuck, Michaela. Normally you're here like 20 minutes early, so I have someone to chat with. No one, there are a bunch of people here early, but no one chatted with me. So examples of this are like 3x plus 5. That is an algebraic expression. 0.23y minus 0.423. That's an algebraic expression. They don't have to be pretty. They can have ugly decimals in them. They can have even worse fractions in them. But they're still algebraic expressions. These numbers in front of the letters, these are called coefficients. That's the name for them, like the word efficient with the CO in front of it. And what they act as multipliers. Remind me in class, it's fucking Taco Tuesday. We need to talk about Taco Tuesday. I need to know where everybody likes Taco Tuesday at. What? Okay, wait. This class is a busy class, so I wanted to say it before I forgot. So we got a couple properties we need to talk about here. First one is called the distributive property. And it's got the word distribute in it. Like Santa distributes presents. Distribute is like share. Share around. Just leave it as share. It almost always has parentheses inside involved when it happens. What this means is to take the 2, it's out in front, so this is like multiplication. We don't know what x is here. So we can't do the order of operations where we would add x and 7 together. So instead, what we do is we take it and we multiply it by each thing inside. So this would turn into 2x plus 14. Then there's the commutative property. Let's go back to black. In black. It has the word commute in it, which is basically move. Whenever you're commuting, you're moving around. So our shit's going to move around. The idea here is, and this works with both addition and multiplication. A plus B is the same as B plus A. And A times B is the same as B times A. Maybe I should give some examples of all these. That seems like a pretty good idea. Let's go back up and do an example on this one above it. Let's say x equals 1. So I would have 2 times 1 plus 7 on the left there. And on the right, I've got 2 times 1 plus 2 times 7. This leads to 2 times 8 on the left. And this leads to 2 plus 14 on the right. On both of them, we get 16. Both sides, we get 16. Now, multiply the addition stuff. Commutative property. This is like 3 plus 4 equals 4 plus 3. 7 equals 7. And why don't we do 3 times 4? Equals 4 times 3. 12 equals 12. I actually use this a lot. I use this a lot in my head, to be honest. But it does show up throughout stuff we'll do. For example, if I had 8 plus 7 plus 5 plus 3 plus 2 plus 10. I think this is tedious to add up the way it is. So what I do is I reorder the addition where they go in tens. I'm going to move the 2 up to be with the 8. I'm going to move the 3 up to be with the 7. I'll put the 10 next and then the 5. Because now I can do this in my head. 10, 20, 30, 35. And I can do it quickly. Multiples of 10 go quickly when you're adding. And then they'll ask you to evaluate. You guys ready for some more pain? Are we having fun yet?
On fire.
Why? I'm not like, there's no test right now. Why?
There was, I got it done, thank God, but oh my God.
Oh, were you doing one of those support quizzes?
Did the test and then I got like an 80 something, so then it filled out.
Almost
I
all of
came
it.
back and I went in there just kind of, but it took all day yesterday.
Well, you got it done.
Couple hot baths.
If it makes you feel better, that after the midterm, I think there's like only one section. The test on only has a few problems and there's only one homework section to go with it. And everything else we're gonna do in the support course is gonna be actually to do more like stack crunch shit. To show, like, give you more practice with it. Yeah, Michaela.
and stuff in the math column, say you don't do an assignment, does it block it, or can you still do it after it's past due?
You should be able to still do it after it's past due. I'll take a look and verify that though. All right, one other thing before we move on to the next topic. They will have you doing evaluating expressions. Guess what? We just did this. When we did the 3i minus 2.5 squared over 4. What evaluate means is plug in the value and simplify. Plug in the value by replacing the variable with its value. And then simplify. Yeah, there it is. I actually also did it when I said that 2 times x plus 7. And I said x equals 1. So what I did is, and what you'll be doing is you take it in and you put it in place of it. 2 times, let me change colors here. Times 1 plus 7, and then just follow PEMDAS. Please excuse my dumbass sibling. I would do the 1 plus 7 here first, is 8. And 2 times 8 is 16. Finally beat fucking Zelda. 225 fucking hours, at least. Show you.
You have a gaming channel as well?
I don't have a game channel, but I uploaded a picture to Facebook. Just a real quick fun peek. 225 hours or more. Fine, Princess Zelda, complete. I didn't even do everything in the game like I normally do. I'm normally a completionist and I go through and find and do all the puzzles and everything. I was fucking tired playing. That's a lot of fucking hours. So I'm just like, I want to beat it before I get so tired playing that I just say fuck it and don't beat it. That would have made me angry. So now I can leave it alone for a while and then go back and look for other shit in like a couple months. Go back and do some more stuff. All right, next topic in this area. We're doing a lot of stuff with variables still. When we have like on a number line, evaluating on a number line. I don't know that the word evaluate is the right word, maybe finding on a number line. So number lines, we tend to put 0 in the middle, and we increase as we go to the right. And we decrease as we go to the left. We can have negative numbers. In money, we call that debt. When you owe more money than you have, you're in debt. You have a negative balance, overall balance. So like if they want you to find something on the number line, find 3. They want you to put a dot on 3.
That's one of the questions.
That was on one of the questions? I think, yeah. I think that was from last chapter. And I think we talked about it in the previous chapter.
How to look it up. What the heck is funding?
Now let's do more stuff with algebraic. We're going to go from expressions to equations. Equations look like the EQUA looks like the word or part of the word equal. They have equations have equal signs. Three x plus 1 equals 10. What we're doing when we have equations, we can solve the equation for the variable. And when the process of doing this is isolate the variable. Get it alone. By itself. You're a leopard stalking the herd, and you're not isolate the weakest fucking antelope and take that motherfucker down. Isolate. Isolate's a good word. I like it. Isolation sucks. Isolate sounds cool. Okay, so how do we do this? List of recommended steps to do this. In all of this, you want to treat that equal sign like scales. I don't know if they have. I don't know if they still have scales like this in like elementary schools. They had them when I was a kid, even though we had like digital scales, they still showed us these things. The Statue of Justice has these. Every courthouse has this holding it up. Scales of justice. The idea is we got to keep the equation balanced. That is the top priority. Just like the scales are supposed to stay balanced, keep the equation balanced. How that works in mathematics is whatever you do to one side, of the equal sign, you have to do to both sides. both sides. It's about tacos.
How's the weekend? If you don't mind me asking.
It's good. I got to play some Zelda. I got caught up on a lot of work. I played Dungeons and Dragons. I want to say my wife and I watched a movie, but I can't remember what the fuck it was. I have no idea. We didn't like go to the movie theaters. It was like at home. So it could have been a fucking anything. It wasn't Pope's Exorcist. We watched that the other week.
That's on Netflix, huh?
Yeah, that was good. I don't like scary movies. I don't like being scared.
Yeah, I haven't watched this very much.
But it took me like 40 fucking years plus to determine there's a difference between scary and horror. Pope's Exorcist, there's not a lot of scary shit. There's a lot of horror in it. There's demons and fucking all sorts of shit. But I never once felt scared. Lights Out, that show, I was fucking scared. I even fucking whined like a beaten dog in it while I was watching it. Part of the reason I don't like it is I don't like fear. I don't know how that's a fucking good feeling. I don't know why people pursue it.
I used to watch scary movies when I was younger, but when I got to a certain age, I was like, "Ooh."
I watched scary movies like this when I was younger. It doesn't change. Like I will try to watch it. It's even worse now because my wife loves them, and so she found she loves them even more because I scream, and now she can point and laugh at her husband. I've seen her fucking point at me and laugh too, you fucking punk. All right, so how do we keep the equation balanced? Couple things we want to do. A good idea is to get rid of fractions or decimals first. There are some exceptions, as you'll see as we're going through this. The exception being if they are inside parentheses and not outside. And not outside. But we will eventually get rid of fractions or decimals. It makes everything easier. And what did I just have up? 3x plus 1 equals 10. I'm gonna write this over here real quick. There is no decimals or fractions here. We are trying to get x by itself though. That's what we want to isolate. So right now it has something that is added to it. The added to it also includes like subtracted shit. And it also has something multiplied by it. It's got a multiplier. So the best way to go through with this is deal with the added subtracted thing first. And we do that by doing the opposite to both sides. We had 3x plus 1 equals 10. What is the opposite of addition? Subtraction. So right now I've got one extra, it's like 1 extra pound. I want to lose a pound. So I'm going to subtract 1 from the left side to get rid of it. But if I do it on the left side, I have to subtract 1 from the right side. When I do, 1 minus 1 is 0, it goes away, and all I'm left with on the left is 3x. And then 10 minus 1 is 9. We're going to deal with that multiplier. By multiplying by the reciprocal. So reciprocal, like 3, its reciprocal is 1 over 3, because I can write 3 as 3 over 1. The reciprocal of 2/7 is 7 over 2. So reciprocal basically just means flip it. Flip it over. This works if it's being divided by something too, as you'll see eventually. So I've got 3 multiplied by it. I'm going to multiply that side by 1/3. And since I multiplied the left side by 1/3, I'm going to multiply the right side by 1/3. Now, this is the same thing as dividing by 3. Because we can put the fractions together. And I've got 9 over 3 on the right and 3 over 3 on the left. The 3 over 3 cancels out, and I'm just left with x on the left. The right side is 3. Guess what? We're not done. Math has one of the most wonderful things in it ever. It is one of the very few subjects in college or in any class where you can make sure you're right. We can verify we are correct. Verify that x equals 3 is the solution. Solution or answer. Plug it in. We had 3x plus 1 equals 10. And we're going to plug it in. I will have 3 times 3 plus 1. Does that equal 10? We do a little bit of operations. 9 plus 1. Do multiplication first. And we get 10 equals 10. Which verifies that x equals 3 was the solution. That verifies or verified x equals 3 was correct. Now, I want to point out something I see a lot. It's a common mistake for college and anybody studying this stuff. If If. You check your solution. By plugging it in. And it does not make a true statement. Something is wrong. Don't just like fudge the numbers and say that. Don't ignore it. Don't ignore it. Don't fudge the numbers. Find the error. First thing you should probably do is recheck your check. Like make sure you didn't do any math wrong there. And if you're still getting the same thing, then go through your original work and see what went wrong. We will do more of this stuff on Thursday. That's it for that class. I can stop recording.